Let's look at some additional exponent properties. Here are the original exponent properties. We're going to look at some consequences of this first property. First off, what must a to the 0 equal? Think about this. If you had a to the 0 times a to the n, that would have to be equal to a to the 0 plus n. Well, what number is it that multiplied by a to the n gives you a to the n? It must be 1. So this is a sort of a consequence. This is a property. A to the 0 is 1. Another property is a to the m over n must be the nth root of a to the m power. Now, if I could convince you from rule 3 that a to the m to the 1 over m was equal to, perhaps I should put the 1 over n on the inside, 1 over n was equal to this piece here, all would be well. But what is the fundamental property of this piece? Well, that piece times itself, n times, is supposed to equal a. But if you think about this piece, that rule tells you that a to the 1 over n times a to the 1 over n many times, you're supposed to add the exponents. So what's 1 over n added to itself n times? That's n over n, or 1. That tells you this symbol and that symbol are the same, so this rule must be the same. Last, what happens if you have a to the m equals a to the n? Well, it turns out that that happens exactly when, if and only if m equals n. Well, that's very handy to know, because when you have this piece here, you can just say, well, I know m equals n. Let's look at 3 quick problems that use these. I've got an equality. All of these are going to depend on 8 because they have an equality. But I'd really like the base the same between the two. What I'm allowed to do here is I'm allowed to say, well, I know what 9 is. 9 is 3 squared. Now, I'm going to use one of these properties. If you guessed 3, you're right. Probably you weren't guessing. I'm going to write this as 3 to the 1. Notice that because these are equal, I know 2x equals 1, so x equals 1/2. X equal to 1/2, that's the square root of 9, equals 3. See how that worked? Okay, moving to this problem. Notice what we have here is we have 1 over 16. Now I happen to know that 16 is 2 to the 4th, right? It's 2 times 2 times 2 times 2. So what is this right here? 2 to the negative 4 is 1 over 2 times 2 times 2 times 2. So I'm going to reduce this to 2 to the negative 4. Okay? And let's see what I could do here. What I could do here is I could raise both sides to the negative 1/4 power. Raising both sides to the negative 1/4 power effectively cancels those, and so I get 2 equals x. And in fact, you can see that 2 to the negative 4 is 1/16. Okay, how about this problem here? Well, it's fairly similar to the first problem. You probably recognize I need a base of 3. Don't forget that you're supposed to multiply those exponents. We're going to gather like terms. Let's see. If I gather like terms, somehow or other, I'm going to have 0 equals 2. Now, what does that mean? What on earth does that mean? Well, you know 0 does not equal 2, so let's go back and think about what this equation says. When it says solve this, what we mean is I want to know all x values that will make this true. Well, what x values will make 2 equal to 0? None, right? So what x values will make these two expressions equal? None. In other words, this has no solution.